In statistics, we have something called a moment-generating function. For a random variable, a moment-generating function is simply expectation erase xt. Good. But then there is another moment-generating function which generates raw moments. This is a side note. You don't have to know this. I'll call it M of P. Erase xt. Simply x raised k. But both of them are generating functions. And what is the expression here? If you have to find expectation of x raised k. Depends on. Very good. Depends on whether we have a PMF or a PDF. PMF is for discrete random variables, PDF continuous. Let's say we have a PMF. Even in numbers, how would that change?
Then it's the sum of x to the k times by the PMF.
Okay.
Yeah.
Sum all possible outcomes for x. So I'll just call it sum over x because we don't know what the domain of x is. So we take x raised k multiplied by the probability of x. Good. Going back to maybe the first lecture or the second, anytime you see expectation, change it to sideways n. Works out here as well, right? Easy way to remember. It's quite informal, but easy to remember. Good. So, generating function. Look at that, and I'm going to write something over here. You will see the similarity, hopefully. Another generating function. I wrote this so that you can see the connection between autocovariance generating function and generating functions in general. Moment generating function, raw moment generating function, function, x raised k, I'll put it as some function of b should not have used side, but it's going to go away. Anyways, if you have to replace that expression by something, what should you put in there? What would you put in there? Compare this to that. I'll have x raised k, right? Function of b. Could I write it this way? Good. On that one, let's sort of similar, correct? It goes back to treating the autocovariance function as a random variable, or the gamma h's as a random variable and coming up with a derivation. After this derivation, we are going to do something called a spectrum of a time series, which will result in what we call a spectrogram. That is also a way to pick up seasonality and other information that you observe in a time series. That will be related to e raised xt. So write this on the side, and when we get to spectrogram, you will see how things are related. Some people like to call it as a periodogram because it helps us identify periods. Same thing. I say tomato, you say tomato, talking about the same thing. Good so far?
Where is it taken from?
H, okay. I used K here, so my mind went directly to K. Good. So put this on your in your notebook on the side. This later I'll relate it to periodogram. Also, erase. I know what gamma H is from our derivation. We've related all the weights in our series to gamma H, put it as a sum. I'm going to rewrite gamma of B H equals negative infinity to positive infinity. Gamma sub H, going back to our derivation, sum I equals 0 to infinity, psi I plus H. Let's not forget sigma squared A. And the new part I would have B with H. Good. All I'm doing is replacing gamma H by whatever I derive. Okay, I've got H there, I've got I there. I'm going to pull that I out. 0 to infinity. Psi I. Negative infinity to positive infinity. Psi I plus H. Times B raised H. Not a big deal there, it's just psi I. And this is going to work under one condition for this sum. The sum is going from negative infinity to positive infinity. However, the size starts at 0, the index, agreed? So the smallest value that you could have as an index is 0, even though going from negative infinity to positive infinity, which would mean algebra states that I have to start at H plus I equals 0. Do you agree? For everything else, it will be 0. So that sum wouldn't mean a thing, because we don't have size of -1, size of -2, etc. So instead of starting at negative infinity, where should H start? H. it I or is it negative I? In this case, negative I. Do you agree? So this is not a problem. I is going from 0 to infinity. We have sine 1, sine 1, sine 2, sine 3. No big deal. Here I have negative infinity to infinity, which would mean I will have negative indices for sine. I don't have those coefficients. The smallest value for that index is 0. So I plus h, I can even write it as that to be proper. So h has to be greater than or equal to negative I. It has to start at negative I and keep on going. So sigma squared a, I equals 0 to infinity, negative I to infinity, good. Going to do one more adjustment. Your butt does it in a weird way. Look at this one, it's not needed. A simpler way would be this. I'm going to multiply and divide by e raised I. I'm not doing anything wrong algebraically. Do you agree? No, maybe. Nothing wrong. Going to keep the numerator b raised h times b raised I. That denominator, I'm going to move it out. So I will have 1 over b raised I. This part sine I plus h, b raised h times b raised I, b raised I plus h. Good. Almost done. Sigma squared a from 0 to infinity. I can move b raised I from the numerator, denominator to the numerator, psi I, b raised negative I. Good. The next sum if I set j equals h plus I, yet another time, we have h equals I minus j plus this. I told you it's going to keep on coming back. So if I set I plus h equals j, I can change the index back to algebra. If I plus h equals j, when I put in h equals negative I, j will be 0. Agreed? When h equals negative I plus 1, j will be 1. So I can change the second summation and rewrite it this way. Don't they look the same? Sort of, kind of. The only difference is it is B raised negative 1 there. B. But putting all of that aside, that should remind you of something very important. It was on the homework. Simple like that. What is this expression? Hint. If I have xt equals 80, sine of 80, psi 180 minus 1, I can rewrite this expression in terms of b's, correct? Psi naught 80, psi 1 b 80. I can pull 80 out, psi naught, psi 1 b times 80. Yes, we called this something. Psi of b. Psi of b. Yes, and that are one and the same, correct? If I stop at j equals 1, I have those two terms. If I have an AR infinity series, this will keep on going, right? So this is nothing but the transfer function psi of b. That we did at the very beginning. Now you should know as to why the transfer function is important and why psi of b is important. So I am going to write the second term as psi of b. I could write the first term as psi of b raised negative 1, but b raised negative 1 has a name. B is the backward difference operator, b raised negative 1 is the forward difference operator. So whether you write it as b raised negative 1 or you write it as f, they mean one and the same. Good? I will do a problem on this as well. Save that for after the exam. Don't lose this formula and don't lose the other formula that we wrote in terms of the side weights. Both of them are needed. It is going to make our lives a lot easier in terms of estimation. Good. We'll stop there.